our second example of a phase shift. Let's say we were working with an ellipse, and we said that we had x squared over 4 plus y squared over 9 equaling 1. So that would create an ellipse that's centered at the origin. I simply go like this. I know from the x that I can go right or left 2 units. So here's 1, 2. And from the y value, I look to the bottom, it's a 9, so it tells me I can go up or down 3 units. As I connect the points, I get this ellipse. It looks something like that. Now, to phase shift this, if I don't want my ellipse to be here at the origin, you pick a value, whatever you want. Maybe I want to be at 4, negative 3. The new center would be at 4, negative 3. So, just as a quick sketch here, this is nothing beautiful. I go 1, 2, 3, 4, down 1, 2, 3. That would place a new center here. I'm going to still move right, left 2. So I go right, left 2 units. And I would still have to go up, down 3. So there's 1, 2, 3. I know it's not a great picture, it's just a quick sketch. Essentially what I do is I took the ellipse and I moved it to this new center. I redrew the picture. For you guys creating these drawings, you have to have that same concept as how can I change this equation to reflect this new center? And I do that by simply doing my phase shift. I know that my concern is that I want the new x value to be located at positive 4. So I can say x minus 4, quantity squared. The minus, because we look at this as our solution. What make this 0 when x is 4? And that matches that because that's the next value. Over 4, that was our original denominator in this equation here. Plus, now I'm going to do the same thing with the y. I need to be at negative 3, so I'm going to say y plus 3. Y plus 3? The question, y plus 3? Because I want this value to be negative 3, to get a new center at negative 3. And so one way of looking at it is you're just taking the opposite of what you want for your vertex or your center or whatever you're trying to shift to. And that's an example of how you can move an ellipse from the origin to the new point 4, negative 3. Again, notice that this was a 4, this becomes negative 4. This is negative 3, this becomes positive 3. That's what we're looking for. Once you understand the concept of a phase shift, you can move any function. It doesn't matter whether it's a trig function, whether it's a conic, whether it's a rational function. And I'll do a couple more examples just so we get this phase shift down.